Welcome to the video lesson for adding and subtracting rational expressions. We're going to go through a couple examples of how to add and subtract them when we have the same denominator, and then look what happens when we don't have the same denominator. So to begin with, let's look at our first example. We have an x plus 4y over 15y minus an x plus 6y over 15y. So first thing we want to verify is that we do in fact have the same denominator, which we do. So we're going to go ahead and subtract, and I suggest every time that we subtract, we go ahead and put some parentheses here, because you have to remind yourself that a negative sign gets applied to everything that follows it. So what we really have is an x plus 4y, and then if I distribute the negative sign, then we have a minus x and a minus 6y. And then this is going to be over our 15y to the fifth. If we simplify things, if I subtract my x's, they'll cancel out completely. And then we have 4 minus 6, which should be a negative 2y over a 15y to the fifth. And now that we have a single rational function, we don't have a plus or minus, we can kind of do what we did with the previous lesson, where we start to factor and simplify. I can't really factor things, but I can definitely simplify. The y can simplify with the 5, so the y to the fifth, and make it a y to the fourth, which means that our final answer would then be a negative 2 over 15y to the fourth. If we compare this to our next example, I first notice that I do not have a common denominator, and we can't add or subtract without a common denominator, so I need to get things to be the same. I do notice that my second fraction has a 3 instead of a 21, so we're going to start by multiplying by a 7 over 7 to make the coefficients the same. And then my first fraction has an x squared instead of an x to the fourth, so we'll multiply by an x squared over an x squared, again to get our denominators to be the same, so we can then add our numerators. All right, so once we have multiplied, what we have would be 5x squared over 21x to the fourth minus 28 over 21x to the fourth. And again, we want to verify that we have a common denominator before we go ahead and add our numerators. We definitely do. So when I combine my numerators, I'm subtracting, we're going to get 5x squared minus 28 over 21x to the fourth. Just that. And then we want to turn this into kind of what we did with the last couple examples with our previous lesson. Can I factor and simplify? And unfortunately, we can't factor 5x squared minus 28. And since I can't factor that, it is its own term connected again by that minus sign. I have no common factors in my numerator or my denominator, so this would just be my final answer. All right, I'd like for you to go ahead and attempt your turn A. Again, what you're trying to do is get a common denominator, and then see if you can factor anything and cross-cancel to simplify our rational expression. Go ahead and hit pause now, try the problem, and check back in to see the answer. All right, so I noticed that to get a common denominator, I needed to multiply by a 3 over 3 with my fraction on the left, and by a 5y over 5y with my fraction on the right. When I did that, we got 18 over 15y, and then 25y over 15y, which allowed me to add my numerators together. And then once again, unfortunately, this 18 plus 25y did not factor. And since it doesn't factor, I have no common factors to cancel out. So 18 plus 25y over 15y would be my final answer. Okay, moving on with our next example, we see that we have two rational expressions we want to combine, but once again, we do not have a common denominator. So we're going to need to make that happen, and this is going to require a little more multiplying than what we're used to. I'm going to start by identifying that I am missing a x plus 2 with my fraction on the left. So I'm going to multiply by x plus 2 over x plus 2. And then with my fraction on the right, I notice that I am missing the 7, so we're going to multiply by a 7 over 7. And this time we definitely need to make sure we are distributing correctly. So I'm going to distribute this whole expression, and I'm going to do this step by step. So we're going to get 3x squared plus 6x plus 2x plus 4. In my denominator, it's kind of important that we don't multiply things together because we are hoping that at some point something might be able to cross cancel. So I'm just going to write it as what it was. And let me simplify this just a little bit. So we should get 3x squared plus 8x plus 4. And then I'm going to leave some space because I'm going to do the right side right now. When I multiply the right side together, we get plus 14x minus 7. Again, if we distribute that in. And it is, again, over the same denominator. Okay, so we're going to go ahead and add that in, plus 14x minus 7. We'll put this all over our common denominator. Okay, so now we're going to go ahead and combine terms. And if we do, we have a 3x squared plus 22x and then minus 3. And this is all over 7 times x plus 2 times x plus 3. All right, now unfortunately 3x squared plus 22x minus 3 does not factor, so that means that we won't have any common factors across cancel, so we are done with our problem. Looking at our next example here for the your turn, all I really want you to try and do on your own is see if you can come up with the terms you need to multiply by to get a common denominator. So go ahead and set that up and then check back in and we'll complete this one together. Hit pause now, try to get that common denominator and then check back in and see how you did. All right, so my first step, I noticed that 6 is the same as 3 times 2, and I rewrote like that because I saw this 2, which made me think that maybe there's some kind of common factor between the 6 and the 2, and there actually is, which means that for my fraction on the left, I'm really only missing a 3. So my fraction on the right, I was missing that x plus 3 common factor, so I went ahead and added that in, and now we get to do some multiplying. Conveniently, on the left side, there's not a whole lot to multiply. We just multiply that 3, and we get a 3x plus 3. And then on the right side, I'm going to leave that minus sign in between. When I multiply that together, we're going to get an x squared minus x minus 12. And then we have a common denominator. And remember, we're going to put this all over the same denominator, which is, and again, I'm going to leave this as factored, 3 times 2, and then x plus 3 times x plus 5. All right, we're going to go ahead and get a combine our terms in the numerator, but I got to remember to distribute because we are subtracting. So we're going to be subtracting everything from that, which means that we have a, give me 1 second, we have a 3x plus 3 minus x squared plus x plus 12. And I'm going to work with just my numerator for a second. If I combine all those terms, then we now have a negative x squared plus 4x plus 15, and then this is going to be all over our common denominator, which would be 3 times 2 times x plus 3 times x plus 5. Okay, so now what we need to try and do is factor. I'm going to go ahead and take out a common factor of a negative 1 from my numerator, and I get x squared minus 4x minus 15. Again, I'm doing this because it's easier to factor a positive quadratic than a negative. And then we have a common denominator. And unfortunately, once again, x squared minus 4x minus 15 is not going to factor. 15 just has the factors of 3 and 5. There's no way to combine them to get a negative 4, which means that there's nothing else to do with our expression. We have combined it. We can't simplify it, so this is our final answer. Okay, so I look at my second fraction here. I notice I got this 3x squared plus 3x, and it's not exactly factored. And to get a common denominator, normally you want to factor as much as you can. So I'm going to do that. If I factor out a 3x, then we get 3x times x plus 1. And now I can compare that to my denominator on the left. And I notice that it's definitely missing, well, let's factor this a little bit as well. This could be 3 times 3x squared. So I'm missing for sure this factor of x plus 1. And I'm also missing, well, that's actually all that we're missing. So we're going to multiply by x plus 1 over x plus 1. Now my fraction on the right is missing a few things. It's missing an additional 3, and it's missing another x to get this as an x squared. So we're going to multiply by 3x. Again, to get that 9x squared common term. Okay, we're going to go ahead and multiply together now. So we have a 7x plus 7 plus 24x. And then again, for my denominator, I'm not going to multiply it all together. We're going to leave it kind of as is. But I'm going to at least multiply this to be a 9x squared times an x plus 1. And then I can group together or combine my terms. We're going to get a 31x plus 7 over a 9x squared times x plus 1. And again, this 31x plus 7 is not going to factor. Since it doesn't factor, nothing's going to cross cancel. And again, I just want to caution you that I cannot cross cancel the x's, and I can't do that because of this plus sign here is connecting the 31x plus 7. So what we really should do to kind of make that clear is I want to put parentheses around this 31x plus 7 to show that it's connected. And if I wanted to cross cancel, I need to cross cancel the entire factor. All right, one more for you to try. This time I want you to go ahead and try and go all the way through, get a common denominator, multiply it through, combine everything in your numerators, and then see what you get. Hit pause now, and then check back in to see how you did. All right, let's go ahead and compare our steps here. So what I did is I noticed that I had just a single x. Really wasn't much I could do with that. But on the left side, I had a 2x cubed minus 4x squared. And I factored out my greatest common factor, which was a 2x squared. I was left with an x minus 2. And I noticed that I was essentially missing everything in my second denominator except for the x that I started with. So I multiplied by 2x times x minus 2. I went ahead and combined that to make this as 2x squared minus 4x, and then multiply that by 11 to get the 22x squared minus 44x. And then when I rewrote things, I noticed that I had a 22x squared minus 44x plus 3 over this 2x squared times x minus 2. And I left my denominator factor like that in case, again, I could factor my numerator and get a common factor to cross cancel, which once again, we can't cross cancel. So this would be our final answer. With example 5, I noticed that my denominators definitely need some factoring to figure out what my lowest common denominator is. So we're going to go ahead and factor this. I'm going to take out a 3, which leaves me with an x squared minus 4. And I noticed that that can be factored because x squared minus 4 is the difference of squares, so we're going to factor that as well. And I get 3 times x minus 2 times x plus 2. And then I noticed that I can factor x squared minus 5x minus 14 as well. I'm going to factor that, and I would get x minus 7 and x plus 2. So now that it's factored, I can kind of identify what's missing. I noticed that with my fraction on the right, I'm definitely missing this x minus 2 and this 3. So we're going to multiply by 3 times x minus 2 over 3 times x minus 2. And then with my fraction on the left, I am missing this x minus 7. So we're going to multiply by x minus 7 over x minus 7. All right, so when I do that multiplying, let's see what we get here. We have 5x squared minus 35x, and then we have plus x minus 7, and then I'm going to be subtracting, so I'm going to leave that in parentheses. We have 6x minus 1, and then times 3x minus 6. Give this one other set of parentheses. Okay, so I'm going to work with just the numerator for a second here. Slide this up. All right, so I have 5x squared, and then we have minus 34x minus 7, minus, let's see what we get when we multiply this together. Now we have 18x squared minus 36x minus 3x plus 6, but because we're subtracting, we're going to distribute that. Again, we're working with just our numerator here. Oops, squared. So we have minus 18x squared plus 36x. Actually, that should really just be plus 39x. And then minus 6. Okay, so now we got to clean a lot of stuff up. We're going to go ahead and combine whatever we can here. I notice that I can combine my x squares. 5x squared minus 18x squared is going to be negative 13x squared. Negative 34 plus 39 is going to be plus squared. Plus 5x, and then negative 7 minus 6 is going to be minus 13. Okay, at this point, I'm going to go ahead and bring down my denominator, which is going to be, let's look up real quick. It is x minus 7 times 3 times x minus 2 times x plus 2. Okay, all of that stuff. So again, oops, x minus 7 times x minus 2 times x plus 2, and I'll put the 3 up front. All right, once again, we would attempt to factor the negative 13x squared plus 5x minus 13, but I can tell you that it's not going to factor. Because it's not going to factor, we won't get anything to cross cancel, and we are done with this problem. Okay, for our last example, again, I'd like for you to go ahead and attempt to do this. You should factor your denominators first, and then see what you can get in your numerators, combine them to get a single rational expression, and then hopefully complete the problem. Hit pause now, try it, and then check back in and see how you did. All right, so I factored my expressions, and I got my denominators, I should say. With the first one, we had x minus 5 times x minus 2. The second one was x plus 4 times x minus 2. Identified the fraction on the left was missing that x plus 6. The fraction on the right was missing the x minus 5. When I multiplied everything together, we got 5x plus 30 plus 4x squared minus 20x. Combining those terms together, got me 4x squared minus 15x plus 30. Again, we would attempt to factor this, but I know that it doesn't factor, so nothing will cross cancel, which means once again we have completed our problem. All right, that does it for the notes for today. Again, the homework is on the back side. Go ahead and get started, and good luck.